let's say I have been asked to find the angle theta of which the sine is 0.5, right? What I'll do is I'll put in my calculator theta equals to sine inverse of 0.5. I'll put this expression in my calculator. I'll get theta equals to 30 degrees. But when I look at the graph of the sine, I can see that 0.5 is right here and is being given by this 30 degrees, right? This angle 150 degrees, right? And this angle 390 degrees, right? These all three values are giving me 0.5, and also this one, this is also giving me 0.5, and so is this, right? So in reality, there are numerous angles, or let's say countless angles, which will give me 0.5 when the function sine is applied on them. Then why does my calculator only gives me a single answer? Why is that? First of all, this is called the principal value of theta, right? Or PV, principal value, PV, right, of theta. Why is my calculator giving me a single value? Because we've learned in functions that for a function to have its inverse, that function must be one-to-one function. If it is not a one-to-one function, if it is a many-to-one function, like the case in the sine function, right here, this sine function is a many-to-one function, more than one input are giving the same output, that function must be converted into a one-to-one function before finding its inverse. So basically on a calculator, the function sine of x is from minus 90 degrees to positive 90 degrees, right? Because this covers the entire output values from positive 1 to negative 1. So whatever you do in your calculator, whenever you put this sine inverse of theta, it will always give you an answer from minus 90 degrees to 90 degrees. Now what if in our calculation, or in reality, this theta was not 30 degrees, this theta was 150 degrees. So to find the other values of the angle theta, we have two formulas, which are sine of theta equals to sine of 180 minus theta, and sine of theta equals to sine of 360 n plus theta. Alright, why did I add 360 n plus theta? N here is any integer, positive integer or negative integer, but an integer, not a decimal number. So why did I add 360 into this theta? The time period of sine, you can see here, it's 360 degrees. After 360 degrees, or after 2 pi radian, this sine function repeats itself, right? So for example, if this is 30, if I move 360 degrees after 30, or 2 pi radian after 30, I'll reach this point, which is 390 degrees, right? So 390 degrees, sine of 390 and sine of 30 will give me the same answer. Or if I move backwards from this 30, I'll reach this point, right, which is 330 degrees. So negative 330 degrees, not 330, negative 330 degrees. So sine of 30 and sine of negative 330 are giving me the same answer, alright? So n here is an integer. Now if I want to write these formulas in radian, so I'll do sine of theta. I'll just simply convert this 180 and 360 in radians. 180 is pi in radians, sine of, if my angle is in radians, pi minus theta, sine of theta equals to sine of 2 n pi, 2 pi n, or 2 n pi plus theta, where n is an integer, right? And so on. Now negative angles, they simply mean a clockwise rotation. Angle is a major rotation. Negative angles means a clockwise rotation. Positive angles, they mean a counterclockwise rotation. Alright, now moving on to the function of cosine. So let's say I need to find an angle for which the cosine is giving me 0.5 degrees. 0.5, not degrees, just 0.5. The output is 0.5. So what I'll do is I'll put cos inverse of 0.5 in my calculator. I'll get the answer 60 degrees. So 60 degrees is given me 0.5. 0.5 is right here. 60 it will be somewhere here. Alright. But we can see that 60 cos of 60 is also giving me 0.5. So is cos of 300. And cos of negative 60. Because cos is symmetrical about the y-axis, right? Now from here, we know that theta can be 60 degrees, negative 60 degrees, and 300 degrees. And if I take cos of 300, cos of minus 60, cos of 60, I'll get the same answer, which is 0.5. So why did my calculator give me the answer of theta equals 60 degrees? So the expression is the same as in the case of the sine function. For a function to have its inverse, it must be converted into one-to-one function. So your calculator has programmed the values of cos from 0 to 180 degrees. So what the output is, or the number for which you're finding the cos inverse, you'll always get the answer. Let's say cos inverse of y, you'll always get the answer from 0 to 180 degrees, or from 0 to pi, right? This right here is not theta because theta stands for angle. This is, let's say, y, like any number of which you're taking the sine inverse of. Now back to the cosine graph. So whatever the value of y here is, when you take its cos inverse, so you calculate, you'll get the answer which will always lie from 0 to 180 degrees. Now how to find the other values of the angle theta, right? For that, again, you have two formulas, just like in the case of sine. The formula is cos of theta equals to cos of negative theta. For example, cos of 60 was 0.5 and so was cos of negative 60. And the other formula is cos of theta equals to cos one complete time period 2n pi plus theta, because cos repeats itself after 2 pi or after 360 degrees. I've written this formula in terms of radians, right? So where n is any integer. Now if I write these formulas in terms of degrees, so cos of theta equals to cos negative theta, alright? And cos of theta equals to cos 360n plus theta, alright? Where n is 0, plus minus 1, plus minus 2, and so on. This is the principal value of this theta, right? And the other are the other angles. Now moving on to the tangent part. Now here you can see that the time period of tangent is not 2 pi as in the case of sine and cosine. It is negative pi to positive 2 pi, so it is basically pi, right? Negative pi to positive 2 pi. So this is pi. The time period is pi, or you can say 180 degrees. Let's say I have tan of theta equals to 0.5. I want to find theta. I'll do tan inverse of 0.5. I'll get the answer 26.6 degrees. So 26.6 degrees is giving me 0.5, right? This is 0.5 right here. The 26.6 degrees. And so is this angle, this one. And so is this. So is this. And so is this. Now how to find the values of the other angles? This one, and this one, and this one. Alright? So for that, we have this formula. Tan of theta equals to tan of n pi plus theta. Basically, I'm adding its time period into its angle theta, just like it is in sine and cosine. And this is in radians. Pi is in radians. In this case, for degrees, we have this formula: tan of theta equals to tan 180 n plus theta. Alright? Where n is an integer. And so on. So, whatever the value of which you take the tan inverse of in the calculator will always lie from negative 90 to positive 90. This is negative 90. It won't be equal to negative 90, but it will be greater than negative 90, because the negative 90 tan which is in negative infinity till positive 90. It won't reach 90 degrees. It won't be 90 degrees, but it will reach 90 degrees, because at 90 degrees tan reaches positive infinity. Alright, now let's do some examples. Let's say they have asked us to find all the angles, and theta is from negative 360 degrees to positive 360 degrees, for which sine of theta is 0.867. Alright, first of all, what I'll do is I'll do theta equals to sine inverse of 0.867. This will give me the principal value of theta. So I get 60 degrees. Alright, this is my principal value of theta. Now I need to find all the angles from minus 360 to 360 degrees, which will give me 0.867. So first of all, I know that sine of theta is sine 180 minus theta. So theta is 180 minus theta. It can also be 180 minus theta. It is 120. Alright, theta can be 120. And if I do, it was sine of theta equals to sine 360 n plus theta. So if I take n as 1, negative 1, because if I take n as 1, it will exceed the upper limit of this range. So if I take it as negative 1 plus 60 plus theta, this gives me negative 300 degrees. Alright, now if I use this angle as theta, and if I subtract this from minus 360 degrees, I'll get 360 minus 1 plus 120 degrees, we get minus 240 degrees. Alright, so this is your theta, this is the principal value, and these are the other values. Theta 120 minus 300 minus 240. You can see that I use this angle 120 here to find this angle. You can do that. You can also do minus 300. You can also use minus 240 and put it right here and do 180 minus 240, which will give you 180 plus 240, which will give you an answer which will exceed the upper value of this range. So that's why we're going to stop right here. Theta, 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 principal value of theta. Alright, now moving on, let's say we have cosine of theta equals to 0.867. Right? For cos theta, we know that cos of theta equals to cos of negative theta, because cos is symmetrical about the y-axis, and cos of theta equals to, this is in degrees, so I'll do 360n instead of 2 pi n plus theta. Alright, so first of all, from this, if I do theta equals to cos inverse of 0.867, I'll get theta equals to 29.89 degrees. Alright, now this is the principal value of the angle theta. Now finding the other values of theta. So theta is also, according to this, it can be negative 29.89 degrees. If I do cos of negative 29.89 degrees, I'll get the same answer, which is 0.867. Now the other value of theta is, if I take n as 1, 361 and negative 29.89 degrees, if I use this angle, right, I'll get 330.11 degrees. And if I do theta equals to 360 into negative 1 plus 29.89, I'll get minus 330.11 degrees. This is our theta, this is our theta, this is our theta, and also this one. Alright, if I take cos of this and this and this and this, they'll all give me the same answer. Alright, and they all lie in the range from minus 60 to 360 degrees. Now moving on, tangent, let's say I have tan of theta equals to 0.867. Now for tangent, we know that tan of theta in degrees it was tan 180 n plus theta, where n was an integer, right? So first of all, I find the principal value of this theta, which is will give me 40.92 degrees. Alright, 40.92 degrees. Now from this, I'll find the other values of this angle theta. Right? So I'll do theta equals to 180. I'll take 1 as I'm taking n as 1 plus 40.92, 220.92 degrees. Theta equals to n is being taken as negative 1. 40.92. This gives us negative 139.08 degrees. Right? Then theta equals to, that's it. If you find other values of theta that will exceed the range, either exceed its lower limit or exceed its upper limit, right? Which was from minus 360 degrees to 360 degrees. Now if I take the tangent of this angle, I get 0.867. Tangent of this angle, I get 0.867. And tangent of this angle, I get 0.867. But this angle is given by Euclidean, and these angles you have to derive them, right? Principal value is always given by Euclidean. The first value of theta is the principal value. Alright?